We'll now look at Q3. Question 3 has to do with partial fraction decomposition. And with the partial fraction decomposition, we have polynomial long division first, and then we decompose the function. Now, in our first expression, we have the integral of x cubed plus x over x squared minus 1 dx. Now, this expression doesn't look the nicest, but because my denominator is less than my numerator, I'm going to start by doing polynomial long division. There's lots of missing terms. So remember, when we do the polynomial long division, we want to have expressions 0x squared plus 1x plus 0 as a placeholder. And now I have x squared minus or plus 0x minus 1. X squared goes into 3x cubed x times, giving me x cubed plus 0x squared minus 1x. And when I subtract this, I get 2x plus 0 left over. And now I have plus 0 here. And this, as this polynomial, the power is less than the largest power on my divisor. This is my remainder. So this is my quotient, and this is my remainder. So this equals the integral of x plus 2x over x squared minus 1 dx. Now, it might be really tempting to go straight from here into your partial fraction decomposition. And while you can jump into that, if we take a pause and look at what we have, this x squared, the numerator is the derivative. So we actually just have a u sub. U equals x squared plus, or x squared minus 1 du by dx equals 2x, 1 over 2x du by dx dx, du by dx equals 1. But before I do this u sub, we should split this integral. So it's integral x dx plus integral 2x over x squared minus 1 dx, which equals x squared over 2 plus, and again, we're going to keep that constant over here, the integral of 2x over 2x times 1 over x squared minus 1 dx. These cancel, giving me x squared over 2 plus the integral of 1 over u du. Oh, I forgot to introduce my du by dx dx, du by dx dx, which equals x squared over 2 plus the plus ln absolute u plus c, which equals x squared over 2 plus ln absolute x squared minus 1 plus c, which is our solution. And if you did your integration by parts, you would see, or if you did your partial fraction decomposition, you would get x squared over 2 plus ln absolute x minus 1 plus ln absolute x plus 1 plus c. And these would combine using our ln rules to ln absolute x minus 1 times x plus 1, which is our ln x squared minus 1, which is what we have here. So we are perfectly happy in our solution. What's the takeaway of this question? Sometimes when we think it's going to be something like partial fraction decomposition, we get to a point where, wait, I can solve this using substitution now. Take a break, solve it using substitution. Right? So let's take a look at our second example. We have the integral of x cubed plus x squared minus x plus 1 over x squared minus 1 dx. And now I'm going to do polynomial long division, x cubed plus x squared minus x plus 1. Right? And now we're going to divide this by x squared minus 1. X cubed goes into x, or x squared goes to x cubed x times. X cubed minus plus 0 x squared minus x. When I subtract this, gives me x squared plus 0x plus 1. X squared goes into x squared 1 time. X squared plus 0x minus 1. When I subtract them, it gives me 2. So this gives me the integral of x plus 1, because this is my quotient, plus 2 over x squared minus 1 dx, because this here is my remainder. Now, I do need to do partial fraction decomposition here. So I'm going to, again, split it up into the integral of x plus 1 dx plus the integral of 2 over x squared minus 1 dx, which equals x squared over 2 plus x plus the integral of 2 over x squared minus 1 dx. I deal with this first piece, and then now I have to do partial fraction decomposition. Because it's x squared minus 1, I know it's 0x plus 2 over x minus 1, x plus 1. I did a quick little factor there, equals a over x minus 1 plus b over x plus 1, which is 0x plus 2 over x minus 1, x plus 1 equals a x plus 1 plus b x minus 1 all over x minus 1, x plus 1. So 0x plus 2 equals a plus b x plus a minus b over x minus 1, x plus 1, x minus 1, x plus 1. So from x to the 1 term, I get 0 equals a plus b. X to the 0 term gives me 2 equals a minus b. Well, this implies that a equals minus b. So this implies that 2 equals minus 2b, which implies b equals minus 1, which implies that a equals 1. So I have this equals 1 over x minus 1 plus minus 1 over x plus 1. So this equals x squared over 2 plus x plus the integral of 1 over x minus 1 minus 1 over x plus 1, which equals x squared over 2 plus x plus ln absolute x minus 1 minus ln absolute x plus 1, all plus c. And we have our solution. Now, our last example, there's two ways you could look at it. One, you could look at it as x cubed plus x over x squared plus 3x plus 2 dx. This was the way it was intended to be, but there was a typo and there's an x missing, which you could solve, and I'll leave for you guys. But we can solve it as given, which is x cubed plus x over x squared plus 3 plus 2, which equals the integral of x cubed plus x over x squared plus 5 dx. We start with our long division, x cubed plus 0, x squared plus x plus 0, x squared plus 5, x times x squared equals x cubed, plus 0x squared plus 5x. When we subtract, we get minus 4x plus 0. So this equals the integral of x plus negative 4 over x squared plus 5 dx, which we can integrate using a simple substitution. And I'm going to leave the remainder of this substitution part as an exercise for you guys to work with. But we get x squared over 2 minus 2 ln of x squared plus 5 plus c. Remember, the absolute x is not required, as x squared plus 5 is always positive.